It's probably, you probably missed a little bit in the video. I don't know. Okay, I forgot that it only has 25 minutes of recording, or sorry, 30 minutes of recording, and then I have to stop it. Stupid laws.
What?
There are laws about different cameras and how you sell them and how much they're allowed to record. So that camera can only record 29 minutes and 59 seconds at a time, because if it records 30 minutes or more, it has to be sold as like a camcorder or something. It's stupid.
That's, yeah, one of the cameras at the APC, it'll just like stop and start the video again. So,
Oh.
like,
That must be a nice feature.
yeah, well, it's nice until you have to edit all the videos back together.
Well, sure, but like you don't have to manually like go push the button again.
Yeah.
You know. All right. So here you can see where the image is formed, right? We cool with that? All right. Let's look at another one. This one you notice was outside the focus. We're gonna do one now inside the focus. Okay. So I'm going to start with a light ray traveling from the focus, and here's the way to think about this: is I want a light ray that's on the same line as the focus. Okay, so it's really coming just from here, but it has to follow that angle. Does that make any sense?
Mm-hmm.
Well, it's going to bounce back parallel. One that's parallel is going to go back through the focus. Now here's the problem: these arrows don't cross, right? So my reflected arrows don't cross. I don't have a real image formed. But just like with the mirror before, if I trace those back through the other side of the mirror, then I can see that they converge. So here we see a virtual image produced by this spherical mirror. Worth going back to mention, if I put a piece of paper here, the arrow would land on that piece of paper. Like you'd be able to see it on the paper. Does that make sense? For this one, obviously it's on the other side of the mirror, so I literally can't put something there. So it should be obvious it doesn't produce a real image. All right, one more. Oh, sorry, this is a convex one now. So notice the mirror is now bulging outwards and the focus is on the other side. We're going to follow the same rules though, okay? So notice this, my parallel light ray that comes in, well, it's going to not go through the focus, it's going to reflect as if it came from the focus, like that. Then I'm going to draw one going to the focus, and then it's going to reflect back parallel. Now notice that these two don't converge, so I can trace these rays back and see they converge there, and there's where my virtual image is produced. So when you draw ray diagrams, you're just drawing lines. We're picking the behavior that we understand for two different things, and we're following it through. All right, here's what I want you to see. For concave mirrors, they're the complicated ones. So those are the ones that they could produce real images, they could produce virtual images, and what really matters is where you are in relation to the focus. And that's what we have here. So these slides go through in tedious detail what you get with different things. I'm not going to go through all of that with you guys today because I don't have a ton of time. We're going to talk about lenses. Convex mirrors are the simpler ones. They basically always work the same. So convex mirrors will always produce a virtual upright and reduced image. It's simple. All right, now lenses. So these are interesting because this is how like glasses work and telescopes work and all sorts of fun stuff here. A lot of the cool things that we use actually use compound lenses, so like one lens followed by another lens, like telescopes and microscopes, they both use compound lenses. But this definitely applies to things like glasses. So let's just do it. So two types of lenses that you have to know about for AP Physics. There are more types of lenses, but the two you need to know about are converging lenses, also called double convex lenses, and diverging lenses, also called double concave lenses. So if you look here, you can see it's like I took two convex planes and smushed them together. If you look here, it's like I took two concave planes and smushed them together, right? That's why they're called double convex and double concave. Now, notice for the converging lens, if I imagine a bunch of parallel light rays, all of those parallel light rays will converge at the focus. if you imagine for the diverging lens parallel light rays, they all diverge as if they were scattered from the focus. Do you see that? The behavior here is a bit weird to get used to, but that's what we got. There are other types. Here are some pictures of other types. You don't need to know about them. Basically, you need to know that one, you need to know that one. So, how do we predict images? Well, we look at ray diagrams, and we just use those again. So when we look at our ray diagrams, we'll use the same rules. We'll draw a parallel line that goes through the focus, a line that goes through the focus, then goes parallel, and then a line through the center, because that really is it's kind of like a check to make sure you got everything right, because it should converge to that one. Now, notice that before the light was reflecting, and now it's passing through. All right? So we're going to do these just slightly differently. Here's an example of a convex lens. So I'm going to draw a line that goes parallel, and instead of it reflecting as if it was coming from the focus, we're going to draw it go through the focus. Does that make sense? I'm going to draw one that goes through the focus and then goes parallel. And then just to make sure that this makes sense, I'm going to draw one that goes through the center of the lens. Now if I do that, you can see that these three light rays, they actually converge at that point, right? So this is going to produce a real image. Again, if I put a piece of paper here, it would actually show up on that piece of paper. Make sense? Another example, this time we're inside the focus, so we'll see what that looks like. So I draw a ray as if it's coming from the focus, and it goes parallel. One that's parallel and then goes through the focus, and then one that goes through the center. And you can see that this is all scattered. So what do? I trace it back, and I can see that it all converges here. Now that, because it converges there, only by looking at how these rays trace back, that will be a virtual image. Okay, so concave examples. I follow the same rules here, but now what I want to see is on the other side, instead of them coming to the focus, that's where we're going to see them scatter. So the parallel one is not going to go through the focus. It's going to move away as if it's coming from this focus. Then I'm going to draw it as if it's going to that focus, and it's going to go parallel. Then I draw one through the center. Once again, they all scatter, and so I could trace them back, and I see my image produced there. Make sense? Okay, so that's ray diagrams in a nutshell. There are equations that go along with these that I thought I had put in this slideshow, but they're not. So I'm guessing there's another version of this slideshow somewhere. They're on your formula sheet. When you get to that point where you're using those equations, one thing you want to be careful of is the sign convention. Okay, so all the equations are in terms of the distance from the lens, and they'll have the distance of the object, the distance of the image, the focus of the object, the focus of the image. I'm not going to try to explain all of them to you now because I don't have the equations in front of me, but the sign convention there is really, really critical. So make sure that your image and objects are the right sign, either positive or negative, and that your focal lengths are the right sign, either positive or negative. They're simple equations to use, but people have a hard time with the sign convention. So be really careful there. Make sure you understand the sign convention before you try to use those equations. That's the biggest thing that gets in the way of people being successful with that. Does that make any sense? Okay. We're not going to have time for you guys to finish it, but there is a good video on polarization. Where did it go? Were you here? I thought I had a video on here. Oh, I can't find it, so never mind. End of class.
Yay.
Yay.